I call these questions double triangle questions. We've already had triangle questions. Triangle questions are the ones where you get enough information to draw a triangle in a quadrant and label two sides of that triangle, and you can do a squared plus b squared equals c squared to find the rest of that triangle. So we've already had triangle questions. These double triangle questions are ones where you have to draw two triangles because there's two angles. So we read the first phrase, give an angle alpha in standard position in quadrant 3 and cos of alpha is -3/5. That type of phrase is similar to triangle questions you've done in the past. And so from that first part, I know that alpha's in quadrant 3. I can draw a triangle with a reference angle for alpha. And since cos is adjacent over hypotenuse, I would know that that part of the triangle is 3/5. A squared plus b squared equals c squared, and you could find out that the other side was 4. So we can draw a triangle for alpha. Similarly, the second phrase, and angle beta is in quadrant 2 and sine of beta is 1/3. That means we have enough information to draw another triangle with a beta reference angle. And since sine is opposite over hypotenuse, we could label those two sides a squared plus b squared equals c squared. Could figure out the other side to be √8. So the first two phrases really tell us that we can draw two triangles. And then the question is asking, I'm going to draw a line right here, it's asking us to figure out what is sine of alpha plus beta. Well, that's one of our sum and difference formulas that we just have. If we go to our formula sheet, we can write that out as sine alpha cos beta plus cos alpha sine beta. That's our formula. And from our two triangles, well, from the first triangle, we already knew that cos of alpha was -3/5. We now can look at our triangle and say, I know that sine of alpha, opposite over hypotenuse, is going to be -4/5, negative because it's in quadrant 3, and 4/5 because sine is opposite over hypotenuse. And similarly, we already knew that sine of beta was +1/3. We can now look at our triangle and say, I know cos of beta is -√8/3. Negative because it's in quadrant 2, √8/3 because cos is adjacent over hypotenuse. So from our triangles, we know cos of alpha, sine of beta, cos of beta. The next thing we have to do is just plug things into our formula. And right now, I'm going to get you to do the next step because there is a common mistake that about 50% of you make in this next step. Despite the fact, if I would show you the right step next, still 50% of you, when you do it for the first time on your quiz, are going to make the mistake. And if we're going to make that mistake, I want you to make it now and find out about it rather than kind of ignoring what I do in the next little bit, just copying it down and then making the mistake on your quiz and test. Okay? So I'm going to take a survey, see if you guys are at about 50%, see how many people make the mistake. You just have to, we've got all of our informations here, you just have to write the next line. You don't have to go beyond that, just write the next line. So for this next step, you have to ask yourself, do I know alpha or do I know all of sine alpha? If I look over here, I know all of sine alpha is equal to -4/5. I don't know what alpha is. So when I go to substitute it, I'm substituting all of sine alpha for -4/5. Not just the alpha. The sine is gone. We don't write sine again because we don't know what alpha is. We know all of sine alpha, so we substitute all of sine alpha for -4/5. We know all of cos beta is -√8/3. Plus, we know all of cos alpha is -3/5. And we know all of sine beta is 1/3. So again, the common mistake is in that line. You keep the sign in the cos because you're used to substituting in values for a variable. You're not as used to substituting a value in for a whole function. So it's that idea that's important, because sometimes we're going to be putting in values for alpha and beta. We're going to do that later today. Sometimes we're putting in values for all of sine alpha. So if we made that mistake now, we want to be really thinking about that and seeing, oh yeah, that does make sense. But if we don't think about that now, then you're probably going to make that same mistake come the quiz or the test, and that's what we want to try to avoid. So now when I'm multiplying this out, I'm going to get negative, well, this will be positive 4 root 8 over 15 plus negative 3 over 15. I have a common denominator, so we do need to write our final answer as a single fraction. 4 root 8 minus 3 all over 15. Now you could simplify this, okay, because the square root of 8 is equal to 2 root 2. You could simplify this. 2 root 2 times 4 will be 8 root 2. Oh, that's not a 2. 8 root 2 minus 3 all over 15. And because that minus sign groups this all together as one thing, we can't simplify the 3 and the 15 because that top is one big factor. And the only way you could simplify that is if you could factor something out, but there's nothing in common that could be factored out, so this would be as finished as we could do it. We write our answer as a single fraction. We've done that. Nothing else can be simplified, but you could leave it as 4 root 8 minus 3 all over 15. That would be fine. But if it was a multiple choice question and they had root 8 simplified, you have to be able to do that. Okay, questions for practice on this one, double triangle questions, are 8 and 13.